Hi guys, this is Mohit Goel, your maths coach with another problem. For more ideas on how to solve maths problems which include multiple concepts, make sure you subscribe to this channel and click on the bell icon. Let's get started.
Now let's discuss a question. So problem is there on your board which says that if f of x is a twice differentiable function satisfying these conditions, and these conditions are f of a is equal to 0, f of b is 2, f of c is minus 1, f of d is 2, f of e is equal to 0, where a, b, c, d, e are following a particular order. Then what we are looking for? So we are looking for the minimum number of solutions, minimum number of zeros of this equation g of x is equal to 0, where g of x is defined as f dash x, it's a square, plus f double dash into f of x in this closed interval a to e. This is one of the best problems of differential calculus. Now, I will show you the solution. So if I arrange all these numbers on the number line, so this is your number line, and let's arrange them. So this is A, B, C, D, E. Your function is differentiable, and differentiability implies continuity. So this curve is a continuous curve without any break. So f of a is 0, okay, 0. F of b is positive, positive. Then f of c is negative, f of d is positive, and f of e is 0. This curve cuts the x-axis minimum at 4 points. 1, 2, 3, 4. Because we are looking for minimum number of solutions, that's why I am taking minimum number of points of intersection. Otherwise, between B and C, ये कितने भी turn ले सकता है. That's why only taking one case where it cuts the x-axis at one point. This. So let's assume this number as x1, this as x2. So that's why for f of x is equal to 0, we are having minimum 4 solutions. If I break this interval a to e into sub-intervals like a to x1, x1 to x2, and then x2 to e. Your function was continuous differentiable in this closed interval. It means it will be differentiable in all these sub-intervals. And at the same time, according to the graph, we can say that f of a, f of x1, f of x2, f of e all are equal to 0 because these are the solutions. So if I use Rolle's theorem in all these subintervals, so if I take this case, because differentiability is there, continuity is there, and at the same time at endpoints values of the functions are equal and equal to 0. And that's a special case of Rolle's theorem, which says that between any two solutions of f of x is equal to 0, there exists at least one solution of f dash x is equal to 0. So that's why between a and x1, I can take one solution of f dash x is equal to 0. 1. Then similarly between c and d, right? Like in this case, one solution is here. So we are having for f dash x minimum 3 solutions, right? So for f dash x is equal to 0, we have minimum 3 distinct solutions. Okay, now so for f of x is equal to 0, we are having 4 different solutions. For f dash x is equal to 0, we are having 3 different solutions. That's why for this equation, we are having 7 distinct solutions. So for f of x, solutions are a, x1, x2, e. And for f dash x, solutions are, let's assume solutions are x3, then solutions, this is x4 and x5. If you look at the problem, your problem was, we were looking for the minimum number of solutions of g of x is equal to 0. So what is your g of x? Your g of x was f dash x, its square, plus this is f double dash into f. And we can write this expression as d by dx of f into f dash. It's like first into derivative of second, that gives you f double dash x, plus second into first ka derivative, which gives you f dash x square. So if you are looking for minimum number of solutions of g of x is equal to 0, that means for this equation, right? Now if I arrange all these numbers a, x1, x3, x4, x2, x5e on the number line, so if I arrange them, so this is your number line. So we had a, then we had x1, and between a and x1 one solution was x3. Similarly x2, between x1 and x2 one solution was x4, and then e, and one solution between these two was x5. That was for f dash x is equal to 0. Now if I use the same theorem, Rolle's theorem, in all these subintervals, the reason is because we are looking for the minimum number of solutions of this equation. So if I assume this as h of x, so what we are looking for? We are looking for h dash x is equal to 0. The minimum number of solutions of h dash x is equal to 0. Now look, your function is continuous, your function is differentiable. So if I go for h of x, yes, it is differentiable, it is continuous, and at the same time at all these points values of h of x are equal to 0, because these are the solutions of hx is equal to 0. So when I apply Rolle's theorem, the special case of Rolle's theorem, which says that between any two solutions of h of x is equal to 0, there exists at least one solution of h dash x is equal to 0. That's why between these two, one solution of h dash x is equal to 0. Between these two, one solution of h dash x. One solution here, then again one solution, and so on. So these are the solutions of h dash x is equal to 0. That means the minimum number of solutions of this equation are 6.